Okay, so we're talking about rotations in geometry, and specifically at first here we're looking at some rotations about the origin, which is right there where my two axes meet, of course. And I just want to give you some general food for thought about how this works. And one thing I want to talk about is how the orientation of the figure changes. In other words, right now, this figure, this little parallelogram, FGDE, is longer side to side than it is top to bottom. It's bigger, right? If I rotate it, it's going to be the opposite that's true. The longer direction is going to be top to bottom instead of side to side, and that depends, that's if I rotate it 90 degrees. If I rotate it 180, it's back to that. So that's something to keep in mind. So let's look at an example of that. And I'm trying to make it as easy for you to see me do this rotation as possible. So I've got a little paper clip to hold my center in place. Let's see if this helps. Okay, let's say I go 90 degrees clockwise. Well, now, if I can get it, it's going to be over there. Okay, what if I do 90 degrees? And it gets a little bit off each time, so I'm having to adjust. So use your imagination, suspension of disbelief. 90 degrees counterclockwise. It's going to be right down here. What about 180 degrees counterclockwise? Let's see if I can hold it over here. And this is with my center at the origin. There it is. So let's look at where point G specifically goes. Okay, point G, let's see if I can make it. Nope. All I've managed to do is smear it. Made it a little bit pinkish, but I'll just point it out as we rotate. Point G, which is currently at -2, 3. If I rotate it 90 degrees counterclockwise, that was G. This is still G right here. This is G prime. Now it's at -3, -2. So this goes with what I was telling you about. Remember when we said the longer part will now be the taller part? Well, this goes with a characteristic of coordinates, of what happens to coordinates when you rotate. And I've spoken about about this with some of my classes, and with some of my classes we haven't talked about it yet. So we'll get to that if we haven't. And that is, if I rotate 90 degrees, these two numbers kind of trade places. And that goes with the long way being the tall way now. Okay, so instead of -2, 3, G is now at -3, -2. So the 3 comes first and the 2 comes second. And then if I bring it on over to 180 from its original location, we're back to 2 comes first. It's right down here. To -3. Now 270 from its original location puts it right here. Here's the G. It's at 3, 2. So here the 3 is first. So the 2 and the 3 trade places as we go around. When it's gone 90, the 3 comes first, the 2 comes first, the 3 comes first. And as far as coordinates go, the coordinates end up with, they have to match really, the quadrant you land in. Let's look, for instance, at F. Actually, let's look at E. Here's E. E is currently at -6, 1. Okay? So let's see what happens to E as I rotate around. I'm going to see if I can mark E. I did. There it is. So E has a circle. Sorry about the announcement. So if I go 90 counterclockwise, now here's E. E is at -1, -6. So the 1 comes first and the 6 comes second, but they're both negative because it's in this quadrant, the quadrant where everything is negative, negative, negative. If I take it and now go ahead and continue on to 180 from the original, now E is at 6, negative 1. The 6 is still the first coordinate, the 1's to the second, but the signs are both opposite, positive 6, minus 1, because it's in this quadrant where we have positive, negative. And if I go ahead and carry it around to 270 from the original, sorry, it's right there at 1, 6. One of the reasons I wanted to show it to you this way is because when we talk about doing this in such a way that we're talking about the components of getting to a point, like we say we're going to go up 3 and left 2 or something like that to get to G, the letter L looking shape does the same thing as we rotate around. Okay? And it really helps to be able to see that, to be able to visualize how those directions are turning. Okay, so let's go ahead and talk about rotating point E without using a transparency that we can spin. So point E, one way I can do it is I can say if I'm going to rotate it, let's go ahead and do it 270 counterclockwise. I can say, well, let's see, how do I get to E now from the center? And notice I'm not calling it the origin, I'm calling it the center, so it really doesn't even matter that it's the origin if we talk about this point in terms of how do I get there from the center. Well, I have to go 6 to the left and up 1. It's because my center is the origin that 6 to the left, up 1 is actually reflected in the coordinates. Okay, so if I'm going to go 270 counterclockwise, then I need to think about what happens to left and up. Okay, so here's left, here's right, here's up, here's down. If I go 270 from left, that's 90, 180, 270. Left turns into up if I rotate 270. What about up? Well, here's up where it starts, 90, 180, 270. Up is going to turn into right when I rotate 270, which is the same thing as 3/4 of a turn. So if I go 6 up and 1 to the right, that is going to tell me where E ends up. So 6, 1, 2, 3, 4, 5, 6, and 1 to the right. This is where E prime ends up after a 270-degree counterclockwise rotation. And again, we could use our little handy-dandy transparency spinner to check that if we want to. And I know that some of you are thinking, I can't do it with a transparency, so I'm not going to be able to do it. But the only reason I'm showing you this is just to sort of help you visualize it. Okay? So there it goes. Lands right there at +1, +6. That's the coordinates of E prime. And again, always remember to take it one point at a time. If you're trying to do a whole shape, don't think of it as the whole shape. Think of it as individual points and think about how to do the individual points. Next, we'll talk about how to do it around a point that's not at the origin.